So now for the third session of today, we'll see how to optimize a bit a Snakemake workflow, how to use some decorators to make it more efficient. So we already saw some things we could improve in the previous series of exercises, but there are still some things we can improve. So what could we improve again? The three things we're going to see now are how to avoid hard-coded parameters, how to process a list of files efficiently instead of writing all the file names, and how to optimize resource usage, and especially the number of threads and parallelization here. So to do this, we have a few solutions. The first one is to use config file instead of hard-coded parameters. To process list of files, we can use the expand syntax, and to parallelize, we can use the threads directive. So that's what we'll see now. Snakemake can actually use some external configuration files to make the workflow more flexible. And that means in the end, you will change the config files instead of actually changing the code and the rules, which is often a pain to do and not super convenient, and also hampers reproducibility. There are two formats in which that you can use for Snakemake config file: JSON and YAML. You can see some examples on the right. That's a personal take that I'm ready to assume, but I think that YAML is easier to write, understand, and also you can actually comment it. If you try to add some comments in a JSON file, it's going to crash because it doesn't belong to the JSON syntax. That being said, JSON might be easier to parse for a computer. So pros and cons, but usually, I mean, so far I've mostly used YAML files. These files are imported with the config file keyword, so that's a new Snakemake keyword, and the value is the path to the config file relative to the working directory. So the directory in which you are actually starting Snakemake. And then you can access the config values as you would a Python dictionary, because a config, a YAML or JSON file is imported as a Python dict. So for example, if you wanted to access the samples here, like the sample names, you would use config square brackets quotes samples, and you can do that with every field here. You can also have sub dictionaries, sub parameters here, and in which case you just add some more brackets with keys inside to access them. So now, if you want to take your phone back for a question, is what should appear in the config file? Okay. Right, so someone seems to be really against config file. I'm sorry to say that it's always better to use config file. And then the last two answers, sorry, were kind of a trap. It's a good idea to have everything in config files. That being said, if you have a very large and massive config file with tens or hundreds of lines, it becomes very hard to maintain and to keep track of what's what. Especially, for example, if you want to, I don't know, config the number of threads, then give some paths to the path of some input files or annotation files we use, or things like this. And it becomes very hard to deal with. So what we usually advise is actually the fourth answer, to have a main config file with some main settings, for example. And in this config file, you can also specify the path to other dedicated config files. So for example, if you have a list of samples to analyze, you can have this as a TSV format, so tab-separated format. And you can also add some additional info on the sample. For example, we are mentioning paired reads versus single-end reads. You could actually add this kind of information in this. And then you can pass these smaller config files into a format that you like and that you need inside the Snakemake workflow. So yeah, it's quite similar to Snakefile and Snakefiles. So having one big Snakefile is very hard to maintain. So it's easier to have smaller Snakefiles dedicated, like each of them, sorry, dedicated to one type of task, for example. Yeah. What should not appear in a config file are, of course, everything that's related to credentials, access token, passwords, usernames, things like this. You can use some environment variable instead. Yes, Erika?
Can you make Snakemake rule that creates this sample table? Like having the first rule that creates this TSV file and then use that later?
Yes. But in this case, if you have a rule to actually, so for example, you mean detect, I don't know, all the samples in a folder and create something.
Yes, out of that.
Yes, you can. But in this case, if you already have a function to list all the samples, you can save everything into a dictionary, for example.
You don't
So
need
you
to.
don't really need a TSV like the config file. Like both options are useful. The added value of having a config file is that if you change it, for example, if you add some more samples to process, Snakemake will notice it and it will trigger the rerun to process the new samples.
Mm-hmm. Yeah. Okay, thank you.
Welcome. Yes.
I'm actually having the same problem here, is that I usually start, it's for example, one operation or two, and they decide along the line how many files I'm going to process. And therefore, I cannot really put that, especially if I want to parallelize over the samples, I cannot use them as a wildcard from the beginning. So I don't know in this case what is the best solution. I ended up separating them into two different workflows. So I don't know.
So could you give a bit more details on this? Because I may have a solution, but
Yeah, so typical scenario is when you work with genetics, with variance calling. So you start with one sample and you have absolutely no idea where these SNPs come from. So it could be for
okay,
one
yeah.
sample you have 5 chromosomes and the other you have 10 chromosomes, and you opt to parallelize over the chromosomes because you will handle them similarly, so to say. And therefore I cannot tell. I mean, if I, what do you suggest?
Yeah.
Yeah.
So there is, that's what I was thinking about. So good. There is a solution for this. It's called checkpoints. That's a pretty advanced notion, so we
Okay.
won't mention it too much during the course.
Oh,
But
cool.
the idea of checkpoint is that it forces Snakemake to re-evaluate the DAG. So
Yeah.
when you've got an unknown number of outputs, so for example, your SNPs, after a rule, you can tell Snakemake, okay, now do a checkpoint, see how many SNPs I've found, or how many chromosomes I have to deal with. And then, depending on this, you can split more your workflow.
Okay. Okay. So the keyword is checkpoints.
Yeah.
Okay. Thank you.
Could you, I'll paste you the link, like the
Thank
official
you.
doc link about it. Oh, yeah, thanks, Rafael.
Perfect. Thank you.
Other questions?
Thank you.
Okay, all right. Okay, so now how to process efficiently a list of files, and that's like most of the time that's using the expand syntax. So it's a Snakemake function that aims to expand a wildcard expression to several values. And it's especially useful when you want to define multiple inputs or outputs when they've got a common pattern. So the syntax is, so it's in gray here, expand with parentheses, then the wildcard name, and then you actually give the values of this wildcard. Values have to be a Python iterable, so that means a list, a tuple, a set, something like this. So if, to show you a small example, on the left part here, this rule merge files will actually take 3 inputs, test 1, 2, and 3, and concatenate them into a single output with a result/total.txt. A way to simplify this using expand is to use this syntax. So with the file as a wildcard, and the wildcard can take the values 1, 2, and 3. Of note, expand won't apply this rule, like the rule 3 times once per input. It will merge the 3 files once, it will merge the 3 files into a single file. So that's a pretty efficient way to make things faster and easier. And so when you've got, for example, a lot of samples with some common strings or values or patterns, it's especially powerful. You can use several wildcards inside an expand. So for example, here we're using file and number. And Snakemake will create the combination of all the possible combinations. So in this case, files are test A and test B, numbers 1 and 2. It will create A1, A2, B1, B2, and so on. One way to actually to define the wildcard values is you can also do it this way. So if you compare to here, we actually define the wildcard values inside the expand syntax. We can do it in a way that's a bit nicer and also easier to change by actually defining the values outside in the expand syntax. So basically, these values will be lists, Python list, and you can give them as arguments of the expand function. Yes, Erika?
In this case, then the Snakemake will not complain that the wildcard is not present in a whole input and output. Is it correct?
No, it won't. You're right. Because you're already explaining Snakemake what to do, so it knows everything.
Yeah, thanks.
And that's also related to what you're saying here, is that the wildcards inside the expand function are independent from wildcards in the rule. So for example, here the file wildcard in black won't be propagated to the file wildcard in red, because the red one is inside an expand function. But what will happen is that Snakemake will try to match this wildcard to the results of the expanded files. And finally, a bit of resource optimization with the thread directives. So new directive, we already saw input, output, shell log. That's a new one. And its value is useful to control the number of threads to allocate to each job that's created or spawned by rule. Yes?
Sorry, just to return back to the example of using 2 wildcards in the expand. I don't know, but usually it always complains about not using the second wildcard in the output. It never let it go, at least in my case.
Even with expand functions?
The expand function as an input, yes, but as an output, if you are using multiple wildcards, it triggers error. And sometimes also with the logs, if you have logs and then it will tell you to produce the logs as well.
Yes, but that's because so if you have two wildcards in the output, you need to have two wildcards in the log, in the benchmark, and in the input, except in the case of the expand. Um,
Yeah,
um,
I just
let me,
realized I'm mixing because I use the expand typically also in the rule all, and that makes
Mhm.
independent rules when I do that. Yeah. Okay.
Yes, yes, yes. So for example, if you had something like, for example, if you wanted file underscore one
Mm,
as an output here, if you've got file in file and one in number, Snakemake would understand it and make and match the two.
okay. Okay.
Yes, Tessa?
Yeah, I was just wondering, and then Hor mentioned it, with the rule all, because I don't want to expand for every rule I have, right? What if I want to just take in files at the top and then it knows every time that they're all expanded? Is that with the rule all?
Yes, the idea is to have one expand in the rule all. So for those that are not super familiar with Snakemake, you'll soon see what is the role and the importance of the rule all. For those that do know or already know about it, the idea is to have a single expand in the top rule, so the rule all.
Okay,
And in this case, if you set up your workflow properly, it will understand like all the rules it needs to trigger and run afterwards.
thanks.
Okay, so back to threads. So it's a directive. It can take many types of value, but usually what we use most of the time is an integer, and it allows you to allocate a specific number of threads for each job created by a role. Something important to note is that if you don't increase the number of cores, so the C parameter in the snakemake command, if you leave it to at 1, for example, snakemake will downscale everything, all the rule requirements to 1, which makes sense because the C parameter is global, and so that's the total number of snakemake of cores that snakemake can use. It's a bit different when it's run locally, but we're not going to go too much into this. Two important things about threads. First, check whether your software can actually multi-thread. That's not that because you give more CPUs or more threads to the software that it will be able to use them. Some packages run on a single thread or single core, and Snakemake won't be able to force a software to run into multi-threaded mode. And don't forget to actually assign them in the command. So in this case, command, usually you have a dash dash threads parameter or cores or something like this. And related to one of the questions we had this morning, the difference between cores and threads. Cores are actually physical units that sit on the motherboard. So one core is like one block of physical, like one block of physical chips. Threads used to be equivalent to cores, but with technology advancing for a few years now, some cores can actually multi-thread and have two threads. That means they can execute two series of instruction in parallel. In practice, it's not really in parallel. They often jump between both of them, but that speeds up the execution. So yeah, that's one of the. Yes, Felicita?
And for example, if you want to use GPU instead of CPU,
You can specify them in Snakemake. I need to check the syntax again, but you can force or ask Snakemake to use GPUs. Let me take a note about this, and I'll send the syntax. Okay, so that's all for the lecture. So now a new series of exercises. In this one, you'll use a config file, like you will create and use a config file. You'll also try to modularize your workflow, so having a main snake file and then sub files with .smk extension. You'll also see how to process list of inputs using expand. And finally, aggregate outputs in a target rule, which is a famous rule all we've been talking several times about already. And if you have time, there is an extra exercise to optimize CPU usage for some of the rules. So if you have time to do this, or if you're more interested in this, go for it.